In this video, we are going to solve all 25 problems of 2022 AMC 10B problems, American Mathematics Competitions. Okay, we will work on the important ideas of these 25 problems, and also the day before exam of 10A AMC 2022, I release a video that preparation for this exam. In that video, I released some ideas that we've used many of them in AMC 10A. Now we're gonna use again many of the ideas I told you before in AMC 10B 2022. Let's start. Problem number 1. It says define X diamond Y to be absolute value of X minus Y for all real numbers X and Y. What is the value of this? Okay, it's easy. We should only calculate absolute value. If you don't know, absolute value is what we consider the difference. For example, absolute value of 2.5. If it is positive, it is positive. If it is negative, you should consider positive. So the definition is absolute value of X. If X is at least 0, it will be X. If X is negative, you should negate that, like negative 2.5. So absolute value of 2 minus 3. So 2 minus 3 will be negative 1. Absolute value of that will be positive 1. Now, 1 minus 1, 0. Absolute value of 0 is 0. 1 minus 2, absolute value of that is 1. 1 minus 3, negative 2, absolute value of that is 2, negative 2. So it is negative 2, and the answer is A. AMC 10B 2022, problem number 2. In rhombus ABCD, point P lies on segment AD such that BP here is perpendicular to AD. AP is 3. This one is 3. PG is 2. So because it is rhombus, this side AD is 5. So all sides will be 5. What is area of ABCD? Okay. If we find BP, let's call this H, the problem will be solved. By Pythagorean theorem, we can use that in triangle APB or ABP. H squared plus 3 squared equal to 5 squared. So H squared plus 9 equal to 25. So if we subtract 9 from both sides, H squared equal to 16. So if we consider square root, H equal to 4. Now the area of, we can say also rhombus is a parallelogram, is altitude times BC plus AD over 2, but because BC, AD are equal, you can say altitude times AD, for example. It's a formula, and it's easy. You can connect B and D and say, okay, this part is H times AD over 2, a triangle, and the other part same, H times BC over 2, and some of them will be H times AD. H is 4, AD is 5, 3 plus 2, which is 20. So the answer of this problem will be D. There are lots of formulas about, for example, quadrilateral. For example, a general quadrilateral, the area is this diagonal does times this diagonal over 2 times sine alpha, and a lot of other things about areas useful in AMC. If you want to learn them, feel free to send a message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 3. How many 3-digit positive integers have an odd number of even digits? So, because we have 3 digits, when it says odd number of even digits, the number of even digits can be 3 or 1. So we have this case plus this case plus 1 digit here and plus last digit here. So for first part, even digits 2, 4, 6, 8. Here, because it is not Leftmost digit, because we have 3-digit number, leftmost digit cannot be 0. This digit can be 0, 2, 4, 6, 8. The next one is 0, 2, 4, 6, 8. Now this part is 2, 4, 6, 8. Because they cannot be even here. We have only one even digit, so it should be odd. It will be 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. And similarly here, it should be odd. We know always odd numbers are 1, 3, 5, 7, 9. We have 5 cases. This part 0, 2, 4, 6, 8. 0, 2, 4. Because it is odd, it will be 1, 3, 5, 7, 9. And this part is 1, 3, 5, 7, 9. The next digit is 1, 3, 5, 7, 9. Next digit is 0, 2, 4, 6, 8. Okay, let's calculate. This part will be 4, 5, 5. This part 4, 5, 5. This part is 5, 5, 5. This part 5, 5, 5. So the first part is 100, the next part is 100, the next part is 125, and the last part is 125. You don't need to write all of them. You can say, for example, 1.9, or you know that odd digits always have 5 cases, and even if it is in leftmost, it has 4 cases. If it is in rightmost, or for example, other digits, it has 5 cases. So if you add up all these numbers, 100, 100, 400, 450. So the answer of this problem is D. AMC 10B 2022, problem number 4. A donkey suffers an attack of hiccups, and the first hiccup happens at 4 one afternoon. Suppose that the donkey hiccups regularly every 5 seconds. At what time does the donkey's 700th hiccup occur? So let's solve. Okay, first hiccup occurs. I can say, let's consider this one. And the time after this 0, it's first hiccup. Now, after 5 seconds, it is in seconds. It is second hiccup. Now, in 10 seconds, third hiccup, it starts. So, if you want to find, let's calculate first in seconds, 700th hiccup. Then, as you can see, it is like arithmetic sequence. Second one is 5, third one. So it has a formula. It helps you a lot. A and this formula memorize. A1 plus n minus 1d. So I want to find A700. A1 is 0. It is A1. It is A2. We want to find A700 is what? A700 is A1, which is 0, plus n minus 1, which is 699, times d. D is time difference, which is 5. So it will be 5 times 9, 45. We have 4, 5 times 9, 45, plus 4, 49. We have 4, 5 times 6, 30, plus 4, this. Or you could say 5 times 700, 3,500 minus 5. Now, because it says it's 50 seconds after, for example, this, it is seconds. I want to change it to minutes. Because I want to change it to minutes, I should divide it by, because each minute has 60 seconds, I should divide it by 60. If I divide it by 60, then it will be 5, yes, 300, 495. Then I multiply by 8, it will be 480, 15. So it will be 58 minutes and 15 seconds. Because when we start, the time is 4. So it is 4. It will be 4:58 and 15 seconds after that. So the answer will be A. AMC 10B 2022, problem number 5. What is the value of this part 1 plus 1 over 3? Before solving this, I should tell you a famous identity x squared minus y squared, which will be x minus y times x plus y. We have similar formula for xn minus yn when n is integer, and for odd numbers xn plus yn. If you want to know these identities and other useful identities, feel free to send message to my WhatsApp number in the description and comments. So if I call this one A is equal to 1 plus 1 over 3, 1 plus 1 over 5 in the numerator, 1 plus times 1 plus 1 over 7. And in the denominator, for each part, I use this identity. So it will be square root of 1 minus 1 over 3, it will be 1 minus 1 over 3 squared. It will be 1 minus 1 over 3, 1 plus 1 over 3. The next one, 1 minus 1 over 5, 1 plus 1 over 5. And the next one is 1 minus 1 over 7, 1 plus 1 over 7. And if you want to simplify, for example, you will see that we have this part, 1 plus 1 over 3, and exactly this part in the square root. And we know that if x is positive, x over square root of x, because x will be square root of x times the square root of x. You can cancel, and a square root of x will be left. So it will be, if I draw this part and know that square root of x over y equal to square root of x over square root of y. So I can consider square root for both numerator and denominator. When we cancel this part and this part, it will be 1 plus 1 over 3 in the numerator because of this that I said. In the numerator, we have these numbers, 1 plus y, 1 plus 1 over 7. And in the denominator, we have what? You could also calculate all of them. The denominator will be 1. Each part, you could calculate each bracket and multiply them together. 1 minus 1 over 7. So let's now calculate each part. 1 plus 1 over 3 is 4 over 3. 1 plus 1 over 5 is 6 over 5. 1 plus 1 over 7 is 8 over 7. All over 3 minus 2 over 3. And 2 over 3. The next one is 4 over 5. The next one is 6 over 7. Now, if you simplify, 3, 5, 7 will be cancelled with 3, 5, 7. Now, 4 will cancel with this. 6 will be cancelled with this. It will be square root of 8 over 2, which is 4. The square root of 4 is 2. So the answer is B. AMC 10B 2022 and problem number 6. It says how many of the first 10 numbers of the sequence 1, 2, 1, 1, 1, 2, 1, 1, then 3 ones, 2, 3 ones, and so on are prime numbers. Exactly in the video preparation for AMC 10A12A, and I say this preparation for AMC 1012, but the day I released was the day before AMC 1012A. I released an idea considering different mods. Then I saw also problems in AMC that working with prime numbers, and I said some mods are important, pay attention to them. So here I say in all of them we have some ones, some 1, 2, and again some ones. For example, n1s, 2, and n1s. So let's consider different mods. If you consider mod 2, they are always odd, it's okay. If you consider mod 3, then sum of the digits is important. I told you in preparation video. It is n, and the reason is you should consider mod, and 10 mod 3 is 1. If you want to know it completely, feel free to send message to my WhatsApp number in the description and comments. N plus 2 plus n mod 3 is 0. Let's calculate them and reject them, the numbers that are multiple of 3. Because the only prime number that is multiple of 3 is 3, but all these numbers are greater than 3. So 2n plus 2, mod 3 is 0. You should know the rules in congruencies, in modulus. you can divide by 2. Why? Because 2 and 3 are co-prime numbers. GCD of 2 and 3 is 1. If they were not 1, you should divide these 3 by that. These are some formulas, basic things in modular that you should know, also useful in AME and other parts. So n mod 3 will be -1, which will be 2 mod 3. So let's call also this number an. So the first one is a1, a2. It says how many of first 10 numbers from a1 to a10. So n mod 3 are bad. So let's write all of them here. a1, a2. I want to see. I can reject which of them. a5, a6, a7, a8, a9, a10. Now for mod 3, let me write this with other color. For mod 3, I reject n that mod 3 is 2. So a2, a5, a8. I rejected all of them. Now, mod 5, obvious, all of them, the remainder last digit is 1, so it's not useful. Mod 4, not useful. Mod 11 can be useful. Why? Because if you pay attention, for example, a1, you should consider from right side plus, minus, plus. So we will see mod 11, it will be 0. And if you consider, for example, a small example that I told you in the video before exam, that check some small example, it will be plus, minus, plus, minus, plus. It won't be 0, it will be 2. If you consider 3 digits, 1, 1, 1, that it will be plus, minus, plus, minus, plus, minus, plus. And it will be 0 again. And obviously, if you have odd numbers, then it will be plus, 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 minus, like this, then minus, then plus, then minus, then plus, and at the end we will reach plus. So this part will be 0 plus minus, this part will be 0, and 1 plus 1 minus 2 will be 0. So if n is odd, so we understand that if n is odd, mod 11 will be 0, there will be multiple of 11. So let's write with other color, mod 11. I reject odd numbers, 3, 5, 7, 9. So the only numbers that are left are a4, a6, a10. Now it's the time to pay attention to pattern of numbers. Okay, again, let's use the small examples. 1, 2, 1. We can say it is 11, 0 plus 11. Why? Because it will be this, plus 11. 1, 2. So we will see the first one is 11 times 10 plus 11, which will be 11 times 10 plus. Now let's consider 2 ones, 2, 1, 1. Again, it will be 1, 1. Let me write here 1, 1, 1, 0, 0 plus 1, 1, 1. Why? Because 1, 1, 1, 2 zeros and 1, 1, 1 will be 1, 1, 2, 1, 1. Okay. And it will be 1, 1, 1 times 1000 plus 1. And it is a composite number. And for n, when we have n ones, 2 n ones, you can say it is equal to n plus 1 ones and how many zeros? N zeros plus n ones, n plus 1 ones to create that. And here it will be n plus 1 ones times 10 to the n plus 1. And it is a composite number, it's not prime. So we proved by considering a small example. So you don't need to consider different mods in this problem. Only by a small example you can find the pattern. Also, I explain a small example. But I wanted to show you can reject some of them with mods. So here we will see, yes, by this pattern, if you consider a small example, you find the pattern and you will see the numbers are multiple of what. So a small example I also used in AMC 10A, 12A, and here, and before exam I told you, and in BMO. So there are some general ideas are so much useful. So I proved all of them are composite numbers. So the number of prime numbers in this sequence equal to 0. So the answer of problem number 6 is A. AMC 10B 2022, problem number 7. For how many values of the constant k will the polynomial x squared plus kx plus 36 have two distinct integer roots? Okay, so let me tell you quadratic formula. If you have ax squared plus bx plus c equal to 0, the quadratic formula is this: x equal to negative b plus minus square root of b squared minus 4ac all over 2a. So here, our polynomial is x squared plus kx plus 36 equals 0. Before exam, in the preparation video, I told you this formula. I also told you if you consider the roots, r1 plus r2, it will be negative b over a. Product of roots will be c over a. So here, if I use the formula x equal to negative b plus minus square root of k squared minus 4 times 36, 144, all over 2. Now, the first thing, let me tell you. Here, the sum of the roots will be r plus r2 negative b over a negative k, r1, r2, the product is 36. So, because some of the roots are integer and it says we have two distinct integer roots, so r1 plus r2 is integer, so k has to be integer. Now, k is integer. This part, k squared minus 444, because it is inside square root, because I want integer roots, k squared minus 444 should be t squared. And we can say t is a positive integer because it cannot be 0, because the problem says distinct. If it is 0, then we have one root, not distinct root. So t should be positive integer. Now, k squared minus t squared equal to 144. Now we factorize k minus t. K plus t is 144. And the problem doesn't say that k is positive or negative. Okay, so let's consider all cases. The first part, k plus t. We know it is greater than k minus t because t is greater than negative t because t is positive. So it can be 144, 1. And let me tell you something. K minus t and k plus t, the mod 2, they are equal. They're parity equal. Both of them, even or odd, because sign has no effect. Because it is equivalent that 2t is 0 mod 2, which is correct. So we conclude what? We conclude that 144 is not possible because both one of them odd, one of them even. And the other one, 272 is okay. 3. And the next one is you should divide by 3. It will be 2448. Is okay. But if you consider 348, one of them odd, one of them even, it's not acceptable. 436 and not multiple of 5. 6 times 24. 8 times 18. And 9 times 16, again, it is bad because odd, even. And if you consider 12, 12, in this case, k minus t 12, let me show you. K plus t 12, if you add these numbers, 2k will be 24 if you add, and k will be 12. And because k 12, then t will be 0. But we know t is positive integer. So again, this case also is bad. Here in this case, 2k, if you add k minus t, k plus t, 2k will be 74. So k will be 37. In this case, 2k will be 40, so k is 20. In this case, 2k will be 30, so k is 15. In this case, 2k will be 26, which k is 13. So we found 1, 2, 3, 4 answers. And look here. If k is even, now in these cases, and also let me check, negative 37, negative 20. I want to say if, for example, 1k that is positive works, the k that is negative also works. Let me show you. For example, k, let's check 13. K13, x will be what? Negative 13 plus minus. 169 minus 144, 25 over 2, which will be negative 13 plus minus 5 over 2. So it will be negative 13 minus 5, negative 18 over 2, negative 9, and negative 13 plus 5, negative 8 over 2, negative 4. If k is negative 13, it will be same, but instead of negative 13, it will be plus 13 plus minus 5 over 2. Again, because look, when you negate these, you should pay attention that divided by 2 should be even. But if k is odd, it is odd, and this part will be also odd. Odd plus minus odd is even. If the first part is even, this part will be even, then even, negative even plus minus even is also even. So it is not important. 13 plus 5, 18 over 2, 9, and 13 minus 5, 8 over 2, 4. Okay, so we will see 1, 2, 3, 4, 5, 6, 7, 8. 4 times 2, 8. There are 8 good answers for K. The answer is B. In this problem, we've used important things, quadratic formula, analyze that, considering mods. I told you considering mods is important. I told you sum of the roots, product of roots, the formula for quadratic formula exactly before exam. So if you want to know important ideas for next exams exactly before the exam, it's not important how hard is the exam, like IMO, BMO for British, AME, USAMO, all these things. If you want to know important ideas, as I said before, feel free to send message to my WhatsApp number in the description comments. Problem number 8, AMC 2022 10B. Consider the following 100 sets of 10 elements each. So the first one, for example, is A1, the next one is A2, next one is A3, and the last one is 100. How many of these sets contains exactly 2 multiples of 7? So if we want to consider AI, it starts from what point? A1 starts from 1, next one from 10. So we can say it is like, consider first one, small a1. Again, for example, it is a1, the first one is a1, a2. So the first one for a1, it is this. For a2, it starts with 11. For a3, it starts with a3. I want to see for ai, it starts with what? You can say by the formula in arithmetic sequence. 1, the first one, a1 plus n minus 1, I minus 1 times 10. It will be 10i minus 9. So 10i minus 9. Let's check this. 10 times 3, 30 minus 9, 20 minus 9. Yes, correct. The next one is 10i minus 8. Up to the last one, plus 9. It will be 10i. So we have this subset. It says how many of these sets contain exactly 2 multiples of 7. So I consider the first one as, for example, x. Okay, I say x mod 7 because we are working on multiples of 7. X mod 7 can be 0, 1, 2, 3, 4, 5, 6. If x is 0 mod 7, so what numbers are good? We know here is x and the last one is x plus 9. X plus 1 to x plus 9. So x is multiple of 7 and x plus 7 multiple of 7. It's good. The next one. X plus 6 multiple of 7. The next one, x plus 13. It is bad because we have up to x plus 9. This one, x plus 5 is multiple of 7 and x plus 12 is bad. X plus 4 is multiple of 7 and x plus 11. Again, it's bad. Here, x plus 3 and x plus 10. Again, it's bad. And this one, x plus 2 is good. X plus 9, both of them are good. They are in this interval. X plus 1 and x plus 8. So we conclude x mod 7 has to be 0 or 5 or 6 mod 7. And here we can see I is from 1 to 100. So x is first element. which is 10I minus 9. So 10I minus 9 should be 0, 5, or 6 mod 7. If you add 9 to both sides, and let's see, what can we do? Let's do something. Okay, let's add 9 to both sides. It will be 9, 14, and 15 mod 7. Then let's consider mod 7, these numbers. 10 mod 7 will be, you should know how to work with mods. And before exam, in my video I released, I said considering different mods, working on mods. It's important also in this problem. It will be 3I, 10 mod 7 is 3, 9 is 2, 14 is 0, 15 is 1 mod 7. Now I multiply both sides. You can multiply by 2 or I multiply by 5. So it's why? Because I want to find I, and 5 times 3, 15, 15 mod 7 is 1. So it will be 10, 0, 5 mod 7. 15 mod 7 is 1, so I mod 7 is 3, 0, 10 mod 7 is 3, 0, and 5. So these numbers are important. Now, if we consider A1, it is from 1 to 100. In 1 to 7, I have from each of them 1s, 8 to 14. So you have 3 here, you have 3 here, to 98, this part, 92. We have also 3 here, 99, 100. Mod 7 here is 1, is 2. They are not good. So how many pack order? You say 3, and it is the first one, it is second one, it is 14th packet. 3 times 14, which will be 42. So there are 42 numbers that are good. So the answer will be B. AMC 10B 2022 problem number 9. The sum 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial plus 2 2021 over 2022 factorial can be expressed as a minus 1 over b factorial, where a and b are positive integers. What is a plus b? Around 2 or 3 days ago, I released a video for preparation for BMO, British Mathematical Olympiad. In that video, I saw some problems. In one of the problems, I explained telescoping rule is what. Here, you should use telescoping rule. As we can see, 1 over 2 factorial. I can write it as what minus what. For example, if it is fraction. 1 over 3 factorial. It is 2 over 3 factorial, sorry. It is what minus what. So, if you pay attention here, if I write, for example, 1 over 2 factorial, 1 over 3 factorial, it will be what? 3 factorial. The first one will be 3 minus 1, it will be 2 over 3 factorial. So it is good. If I use same thing here, 1 over 1 factorial minus 1 over 2 factorial, again it will be this. 3 over 4 factorial, it will be 1 over 3 factorial minus 1 over 4 factorial. And we continue. K over k plus 1 factorial. It will be 1 over k factorial minus 1 over k plus 1 factorial. And we go up to 2021 over 2022 factorial, which will be 1 over 2021 factorial minus 1 over 2022 factorial. And if we cancel, all these things will be cancelled, and the answer, or sum of them, will be 1 over 1 factorial minus 1 over 2022 factorial, which will be 1 minus 1 over 2022 factorial. The problem says we can show it as what? Here, a minus 1 over b factorial. So we conclude a is 1 and b is 2022. The problem says a plus b is what? So a plus b is 1 plus 2022, which will be 2023, and the answer is D. Also here we call it, let me write, telescoping sum, because we added all these numbers, or rule. Also we have telescoping product, Also, some useful ideas similar to this. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 10. Camila writes down 5 positive integers. The unique mode of these integers is 2 greater than their median, and the median is 2 greater than their arithmetic mean. What is the least possible value for the mode? Okay, let's consider the numbers are A1, A2, A3, A4, A5 without loss of generality. Suppose they're all like this. Now, let's read the assumptions. The unique mode. Okay, so we have unique. Of these integers is 2 greater than their median. Median is what here? It's A3 by the definition. We have odd numbers, it is the midpoint. It is A3. So it is 2 greater, the mode, than the median. So it will be A3 plus 2. So here we can say these two things has to be A3 because we have mode, unique mode. So we have at least 2 from that. And the numbers is A3 plus 2. So the only numbers that can be A3 plus 2 are A4 and A5. So it is A3 plus 2, it is A3 plus 2. Okay? And A1, A2, A3, we have these things because the mode is unique. They should be different numbers. So it will be like this, and also A3 will be this. Okay, they cannot, because if A1 equal to A2, then this is also mode, but it says unique. Or if all of them are equal, then it will be mode A3, but we know A3 plus 2 is mode. So they should be all distinct, A1, A2, A3, with also A4, and this part they were equal to A3 plus 2. Let's analyze the next sentence. The median is 2 greater than their arithmetic mean. So the median means A3 is 2 greater than the arithmetic mean. So we conclude that if you take 2 to left hand side, A3, or let's write it. It will be A3 equal to 2 plus mean. Mean is sum of them. A1 plus A2 plus A3 plus A4 plus A5 all over 5. So, if you multiply both sides by 5, left hand side will be 5A3, right hand side will be 10 plus A1 plus A2 plus A3. A4 is A3 plus 2. A5 is also A3 plus 2. So, here, A3, 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 3A3. We subtract 3A3 from both sides. It will be 2A3. And 10 plus 2 plus 2 will be 14. Plus A1 plus A2. Now, here it says, try to find what is the least possible value for the mode. Least possible value for A3 plus 2. So, if you want to minimize A3 plus A2, you should minimize A3. So, and also we know there are positive integers, A1, A2 are not equal. So, if you consider 1, 2 here, then A3 will not be an integer because the left side is even, right side will be odd. So, we need at least 1, 3, some of them 4. You can't reach anything less than 4 because if you want to reach less than 4, some of them should be even. You should reach 2. For 2, A1, A2 will be 1, 1, and they are equal. So, the least possible case is 1, 3. And then, 2A3 equal to 14 plus 4 is 18. So, A3, if we divide both sides by 2, A3 will be 9. And minimum of A3 will be 9. But the problem says find the least possible value for mod. Here, A3 is 9, 9. Let me write all numbers. 1, 3. A3 is 9. 9 plus 2, 11, which 11. These are our 5 numbers. So the mode is 11. So the answer is D. AMC 10B 2022, problem number 11. All the high schools in a large school district are involved in a fundraiser selling t-shirts. Which of the choices below is logically equivalent to the statement? No starts from here. No school bigger than Euclid edges sold more t-shirts than Euclid edges. Part A says all schools smaller than Euclid edges sold fewer t-shirts. So the statement doesn't say anything about a smaller schools. B. No school that sold more t-shirts than Euclid edges is bigger than Euclid edges. Yes, it is correct. Because if you have one school, at least one school, if there exists a school that sold more t-shirts than Euclid edges and is bigger than Euclid edges, the statement will be wrong. So B is correct. C says all schools bigger than Euclid edges sold fewer t-shirts than Euclid edges. No, they can sold. We can say they could sell exactly the same number that HS sold. D. All schools that sold fewer t-shirts than Euclid edges are smaller. No, they can be smaller, they can be larger. This statement doesn't have any problem. Part E. All schools smaller than Euclid edges sold more t-shirts than Euclid edges. For schools that are smaller than Euclid edges, the statement doesn't say anything about it. So the only statement that is equivalent we can say is B. AMC 10B 2022 problem number 12. A pair of fair six-sided dice is rolled n times. What is the least value of n such that the probability that the sum of the numbers face up on a roll equals 7 at least once is greater than 1/2? Okay, first let's calculate that. If sum of the numbers face up on a roll equals 7. So let's analyze this. Suppose first dice, second dice. It can be 1, 2, 3, 4, 5, 6. It can be 1, 2, 3, 4, 5, 6. 1, 6, 2, 5, 3, 4, 4, 3, 2, 5, 1, 6. Okay, the probability of the sum is 7. We have 6 cases, 1, 6, 2, 5 to 6, 1, which will be 6 over 6 times 6, which will be 1 over 6. Now, it says is rolled n times, this a pair of first six-sided dice. It wants to find minimum n. So, for example, let's consider n1. Again, a small example. The probability that you see that is 1 over 6. And we want that it should be greater than 1/2. And if we check, if we multiply by 6, it will be equivalent. That's 1 greater than 3, which is wrong. N2, we want to see at least once that sum is 7. So you can say 1 minus bad cases. You don't see 7, 5 over 6 is squared. 1 minus the case that you don't see, the case that sum is 7. So all cases, the probability is 5 over 6. 5 over 6 times 5 over 6. We want to see, is it 1 greater than 1 over 2? If we check, it will be, let's consider for general n, it will be 1 minus 5 over 6 to the power of n greater than 1/2, which is equivalent that 1/2 is greater. You take this to left hand side, this to right hand side. 5 over 6 to the power of n. Okay, so if n is 1 is bad. We've checked n2. Let's check. Is 1/2 greater than 5 over 6 squared, which will be 25 over 36. If we multiply both sides by 36, 18 greater than 25. No. Let's check n3. 1 over 2, is it greater than 5 over 6 cubed? It will be 125 and 216. If we multiply both sides by 216, it will be 108 greater than 125. Again, it's not correct. Let's consider n4. 1 over 2 is greater than 5 over 6, the power of 4, it will be 625, it will be 1296. If we multiply both sides by 1296, left hand side will be 648 greater than 625, which is correct. So the least n that is possible is n equals 4, and the answer is C. AMC 10B 2022, problem number 13. The positive difference between a pair of prime numbers, pair of primes, is equal to 2, and the positive difference between the cubes of the two primes is 31,106. What is the sum of the digits of the least prime that is greater than those two primes? Okay, first consider that their difference equal to 2, so we have PQ, that q equal to p plus 2, because the difference is 2. So we have p plus 2, that both of them are primes. The positive difference between the cube are this. So I say p plus 2 squared minus p cubed equal to 31,106. Now let's calculate p first. So it will be p cubed. The formula is 3 times first one squared times second one plus 3 times first one times second term squared plus 2 cubed minus p cubed equal to 31,106. Now, p cubed, negative p cubed will be cancelled. So 3 times 2, 6p squared plus 12p. And let's subtract both sides, 8 from both sides, because 2 cubed is 8. It will be 31. 106 minus 8 will be 98, so it will be 098. Okay, now we divide both sides by 6. It will be p squared plus 2p equal to, if we divide by 6, it will be 5, 0, 1, 49, 6, no, 49, it will be 48, and 18, 3. Let me just remove this 0. We don't need that. 5183. Okay, so we conclude what? P times p plus 2 equal to 5183. We will see it is around p squared. So if you want to find around what number times that number plus 2 is this, I consider square root. I told this in my previous videos how to calculate this. Quickly, you say 7 times 7, 49. Then you have 283. You multiply 7 by 2, 14. Then if you want to calculate here, it will be around 72. It will be 71 point, we can say a large number, 71 point here. So, one thing is that you check 71 on, you can also consider one's digit. 71 times 73. If p is 71, let's multiply. 71 times 73, it will be 73. It will be this, and it will be this, 851. It is exactly this. Now, we know left side is increasing function in terms of p, so the only answer is p71, and next number, p plus 2, is 73. They are both primes. And the problem wants what? It says, what is sum of the digits of the least prime number that is greater than these two prime numbers, 71, 73. The next prime, 75, no, multiple of 5, 77, no, multiple of 7, 79. Sum of the digits is what? 7 plus 9 is 16. So the answer is E. Okay, here look, first I'm considering square root algorithm in that problem. Replacement, I told in my previous videos, are useful. If you want to know useful ideas, you can send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 14. Suppose that S is a subset of 1 to 25, such that the sum of any two not necessarily distinct in elements of S is never an element of S. What is the maximum number of elements S may contain? Okay, so for this problem, again, with the preparation video I released before exam of AMC 1210A, exactly the day before that, I said considering a small example is so much useful. Here, 25 is an odd number, so I start with 1. I said for 1, the answer is 1. You select that. For 1, 2, 3, because 1 plus 2 equal to 3, you can't select all of them, but you can select what? You can select, for example, 1 and 3. 1 plus 1 is not 3, so 2 elements here. And we've proved, because we proved 3 elements it's not possible, 2 elements is possible. Now, 1, 2, 3, 4, 5. So here, I can select 1, 3, 5, and sum of any 2 parts, 1 plus 3, odd plus odd, even, or a number plus itself again will be even. So we understand odd numbers works. But how I prove that 4 elements won't work? Because 2, 4 is bad. And let's check. If you want to select 4 elements, because 2, 4 is bad, we can't select both of them because 2 plus 2 is 4. So you have to, if you want to select 4 elements, we have to select 1, 3, 5, and 1 of 2 and 4. If you select 2, 1 plus 2 is 3, it's bad. If you select 4, 1 plus 3, 4 is bad. So we will see 3 elements is a maximum of 3. So we guess that 1, 2 to 2n plus 1, it will be what? It will be n plus 1, the answer. Like 5, that is 3. So for 25, the answer will be 2n plus 1 is 25, and n plus 1 will be 13. So the answer is B. But I will prove it with induction. The students that know induction, I will prove it for them. It's good. But for this exam, only a small example because it is AMC. You can select B. Let me prove it by induction. Suppose for example, n minus 1 is okay, and we want to prove for n this part. And it is the things we want to prove for n. Or let me write. Oh, this part. Okay, so let's delete this part. Okay, so suppose it is, for example, our statement for n. I consider it is correct for n minus 1 for n, and base cases are these. All these things are base case. You can consider one of them 1. So, I know that in 1, 2 to 2n minus 1, I can select at most n. And now I want to prove if we add 2n to n plus 1, it will be at least n plus. So, let's use contradiction here. This part was with induction. If it is greater than equal n plus 2 or greater than n plus 1, then what can we conclude? Here we should select exactly n elements, and here we should select this and this to reach n plus 2. The only possible case is to use all things that we can. Now, here we should select n elements, here 2n to n plus 1. Because we select 2n plus 1, so the things that some of them are 2n plus 1, the pairs, we can select them. Like what? 2, 2n minus 1, we can select at most one of them. 3, 2n minus 2. 4, 2n minus 3. Up to n plus 1. And if we see here, and 1 here, you consider these things. If you see the number of these elements here, from 1 to 2n minus 1, we will see that there are n subsets. And because we select n, so from each part you should select 1 and 1. So we understand that we have to select 1. Because we select 1 plus 2n, we've selected 1, we've selected 2n equal to 2n plus 1, and we've selected 2n plus 1. So that's a contradiction. By using induction and contradiction, we proved that we can select at most n plus 1. This part was a little harder than AMC problem because it is more useful for full solutions exam. But by considering a small example, you can also find the idea. And I explain a small example and solve some problems exactly before exam of AMC. If you saw that video, you could solve this problem and many other problems of this exam, AMC 10A, 12A, and 12B easily. And also for other exams, probably I will release useful videos like that for prepare yourself. And if you want to know all ideas, you can send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 15. Let Sn be the sum of the first n term of an arithmetic sequence that has a common difference of 2. The quotient S sub 3n over S sub n doesn't depend on n. What is S20? Okay, if we consider Sn, the first term, for example, is a, because the common difference is 2. The next term is a plus 2. The next term is a plus 4. And if you want to find nth term, it will be a plus 2 times n minus 1. It is an. And so on. So if you want to find Sn, if you have a formula for this, first part plus first term. If you don't know also that formula, we will solve it in 2 ways. First term, a, plus last term, which is this, a plus 2 n minus 1 over 2 times number of them. It will be what? It will be 2a plus 2 times n minus 1 all over 2 times n, which will be a plus n minus 1 times n. Or if you want to solve it with other solution, this part. You could say Sn equal to a plus 2 plus a plus 4 plus a plus 2 times n minus 1. Now it will be equal to na plus 2 times you factor from 2 to n minus 1. And it will be na plus 2 times n minus 1 times n over 2. You cancel them, and it will be na plus n times n minus 1, which both of them are equal. Now, we know it is Sn. S3n over Sn. So, S3n over Sn equal to what? You use here, let's use this part, let me call this 1 by 1. If you replace n with 3n, it will be a plus 3n minus 1 O times 3n over a plus n minus 1 over n. It says it is constant t. So if we cancel this, and it's correct for all n, a plus 3n, if we cross multiply, minus 1 times 3 equal to t, a plus n minus 1. So if you take it all things to left hand side, then 3a plus 9a minus 9n minus 3 minus ta minus tn plus t equal to 0. So the term that has n will be n times 9 minus t plus 3a minus 3 minus ta plus t equal to 0. So here we can conclude that because it is correct for all n, it is a polynomial in terms of n with degree 1. If it is correct for or more than the degree equals 0, it has infinitely many roots. So all coefficients should be 0. So this is one coefficient of n, it is coefficient of constant term. So 9 minus t has to be 0, so t will be 9. And the constant term will be 0. 3a minus 3 minus ta minus t plus t should be 0. If you replace t with 9, 3a minus 3 minus 9a plus 9 equal to 0. 3a minus 9a will be negative 6a. 9 minus 3 will be 6 equal to 0. So here you conclude a is 1. Now the problem says what? The problem says find S20. If we use 1 here, a plus n minus 1 times n, Sn is a plus n minus 1 times n. A is 1. We want S20, n is 20. So it will be 1 plus 20 minus 1 times 20. Negative 1 will be cancelled. 20 times 20 will be 400. And the answer will be D. AMC 10B 2022, problem number 16. The diagram below shows a rectangle with side lengths 4 and 8 and a square with, okay, so this length is 4, this length is 8, and a square with side length 5 here. 3 vertices of the square lie on 3 different sides of the rectangle. So there are this one. Let me show with blue. This one, this, as shown. What is the area of the region inside both the square and the rectangle? Okay. So if you want to calculate this, I know the whole square is 5 squared. This part. And we should subtract only the area of this triangle. So I say it is 25 minus the area of this part. Okay. If you want to know the area of this part, let's call this one x from this to here. It will be 25 minus 5x over 2. So we should find x. Let's see what can we say. Here, we know it is 4. It is 4. It is a square 5. If we use Pythagorean theorem, it will be 3. Let me tell you why. Because square root of 5 squared minus 4 squared will be 25 minus 16 square root of 9, which will be 3. By Pythagorean theorem. I told you before exam is useful. So it is 3. Now, what can we say about other things? So we know it is 5. It is 5. It is 90 degrees. So if it is alpha, it will be 90 minus alpha. And it will be alpha, it will be 90 minus alpha. So if I want to write triangles, let's consider for example, it is ABC, DE. And also you can say this is alpha because it is 90 minus alpha with similar way. All these triangles are similar. Alpha. And we can say, for example, let's consider FG. AGF, this triangle is similar to triangle ABC. So I want to find x. X is opposite of 90 minus alpha. So here 90 minus alpha is 3. Equal to 5. 5 is opposite to alpha over 4. So x will be 15 over 4. Now, this part will be 25 minus 5 over 2x, which will be 15 over 4. And if we calculate this, it will be 25 minus 75 over 8. And if we simplify this, it will be 200 minus 75 will be 125 all over 8. And if you want to see 120 over 8 is 15, it will 15 and 5 over 8. And the answer is D. Exactly the day before exam of AMC 10A 12A, I prepared a video. In that video, I said Pythagorean theorem, paying attention to similar triangles like this, angle chasing, all these things. For BMO also, British Mathematical Olympiad, and AMC, I released a video before them. And I said these things are the most important things in geometric problems, cyclic quadrilaterals, similar triangles, all these things. If you want to, and there are around 40-50 important formulas in geometry and other topics. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 17. It says one of the following numbers is not divisible by any prime number less than 10. Which is it? So exactly, again, the day before exam, I released a video preparation for AMC. You can see in my channel, in that video, I explained mod 3 the rule is what, mod 5 is what, mod 7. And mod 7 is not so much famous, but we can easily work on that. But exactly the things I told in that video are useful here. So let's check them. Okay, let's consider first mod 2, all of them are odd. Mod 3, if you want to check, let's calculate, because we have 2 to the 606, all of them 2 to the 607, and here 3 to the 607 is 0, because multiple of 3. So let's calculate 2 to the 606 mod 3. I can say it is 2 squared to power 303. It will be 4 power 303. 4 mod 3 is 1, 1 to the power of 303, and equal to 1 mod 3. So by considering this, A will be rejected. And 2 to the power of 607, because it is equal to 2 to the power of 606 times 2, mod 3, because it is 1, it will be 1 times 2, will be 2. So 2 to the 607 plus 1 is bad, because it will be multiple of 3. And all other choices are not multiple of 3. Okay, so if you check 2, they are not multiple of 2. We check multiple of 3, they are not multiple of 3. We should check when they are not multiple of 2, they are not also multiple of 4. We should check 5. 6, they are not multiple of 6 because they are not multiple of 2. 7, 8, not multiple of 8. When they are not multiple of 3, not multiple of 9. So we only need to check 5 and 7. So 2 to the power of, let's consider mod 5. It is working with modulo. Before exam, I told you, working with modulo is important. Know how, when you can divide and the condition, because you can always multiply, subtract, and add like equation, but for divisibility, you should divide by GCD of the thing you divide and mod. And if you don't know them, feel free to send message to my WhatsApp number. Okay, mod 5. Mod 5, 2 to the power of 606. If you want to consider mod 5, it is 2 squared to the power of 303. It will be 4 to the power of 303. 4 mod 5 is negative 1. So it will be negative 1 to the power of 303, which will be negative 1. And it is mod 5, it will be 4. And so 2 to the power of 606 plus 1 will be multiple of 5. So we cancel that. And 2 to the power of 607 mod 5 will be 2 times 4. It is 2 to the power of 606 times 2. From previous part, you can say it is 4. 4 times 2, 8. 8 mod 5. So you can't cancel this part because 8 minus 1 will be 7. But let's consider these parts. We know 2 to the power of 607. Let's calculate 3 to the power of 607 mod 5. It will be 3 to the power of 606 times 3. And it will be 3 squared to the power of 303 times 3. 3 squared is 9. It will be 9 to the power of 303 times 3. If you consider mod 5, it will be negative 1, 303 times 3. And it will be negative 1 times 3, negative 3, which mod 5 is 2. So we will see if we consider these, 2 to the power of 607 is 8, plus 2 is 10. 10 is multiple of 5, so we cancel E, and because only one choice is left, the answer is C. If you want to learn how to work with modulos, because 90% of the problem, you should know divisibility, the tricks, the ideas in divisibility and modulo. If you know that, and the important rules like Euler's theorem and other things, you can solve 90% of number theory problems. If you want to know how to work with these two powerful tools, modulo and divisibility, feel free to send message to my WhatsApp number in the description comment. AMC 10B 2022 problem number 18. Consider systems of 3 linear equations with unknowns x, y, and z, such that a1x plus b1y plus c1z equal to 0, a2x plus b2y plus c2z equal to 0, a3x plus b3y plus c3z equal to 0, where each of the coefficients is either 0 or 1, means a1, a2, a3, b1, b2, b3, and c1, c2, c3. And the system has a solution other than x equal y equal z equals 0. If you replace x, y, z with 0, all 3 equations will be satisfied. It says we have another solution. Other solution. For example, one such system is this, and says, for example, here a1, 1, b1, 1, c1, 0. And these things, it says it has also, if you replace x, y, z with 1, negative 1, 1, x, 1, y, negative 1, z, 1. Then it is another solution of this equation. How many such systems are there? The equations in a system need not be distinct, and 2 systems containing the same equations in a different order are considered different. Okay, so let's consider these three equations because A1, B1, for example, let's consider one of them. And they can only be 1, 0, so if all of them 0, 0 will be 0. If, for example, A1 only be 0, the first one, then we have, for example, if two of them are 0, so x equals 0, look, A1x plus B1y plus C1z equal to 0. If all of them be 0, for all x and y and z will be satisfied. If two of them are 0, then, for example, if these two y, B1, C1, 0, then we conclude x has to be 0, means A1 only 1. If B1 only 1, y is 0, or if C1 only 1, z equal to 0. If two of them be 1, the other one, x plus y is 0, or x plus z is 0, or y plus z is 0. And if all of them are 1, x plus y plus z equal to 0. So we should select for A1, x, B1, y, C1, z. Okay, now we have these equations. For example, if all of them be 0, then, for example, if all A1, B1, C1, 0, all of them, for also A2, B2, C2, then we will see, okay, for all x, y, z, it will be satisfied. And x, y, z are real numbers, okay? The problem says x, y, z with unknown x, y, z. It doesn't say anything about x, y, z, and it can be, for example, any number, but A1, B1, C1, AI, BI, CI can only be 0 or 1. Now, let's see. I try to solve it always minus bad cases. For example, like what? I say all cases are what? We have one case for selecting A1, B1, C1, two case, 3, 4, 5, 6, 7, 8. So I say 8 cases for selecting A1, B1, C1 because A1 has 2 cases, B1 2 cases, C1 2 cases. 2, 2, 2, 8, and 8 cubed. Also for A2, B2, C2, and for A3, B3, C3 minus. So if we select 3 of the same terms, for example, for one of them, we select coefficients such that x equals 0, y equals 0, z equals 0. For example, for first term, you consider this is 0, this is 0, this is 1. For next term, you consider it is 0, it is 1, it is 0. And for other case, you consider it is 0, it is 0, it is 1. So if you consider this case, x, y, z should be 0. And we don't have any other cases, any other solution. So this case is bad. But x0 can be first equation or second or third equation. So we have 3 cases that each equation turns to be x0. So we have 3 cases for x0, 2 cases for y0, and 1 cases for that. Okay, so look, we are considering different cases. And exactly the day before exam, I released a video, preparation video. In that video, I said, considering special cases case by case, and I solved similar problems. And this idea was also useful in AMC 10A, 12A, and also in 12B. We can use this idea to solve problems, some of them. Now, the next case. So we've selected 3 from one part. If we select 3 from this part, x plus y0, x plus z0, y plus z0. Again, it results only 0, 0, 0. Why? Because here y is negative x, here z is negative x. So these two parts, y equals z. Because y equals z, here it will be 2y equal to 0. So y equals 0. Similarly, x0, y, z0. Because when y is 0, here x will be 0, and here z will be 0. So in this part, again, we say 3 factorial, to which equation be x plus y0, and other cases, 3 factorial. Now, here we've used 3 from one part, and it was this. If you want to use 3 from this, it will reach many equations. If you want to use 3 from this level, again, you can select many things like 1, 2, negative 3, or 1, 0, negative 1. So these cases are not bad to subtract. Now, let's consider 2 from one level, 1 from other level. For example, 2 from this level and 1 from this level. If we select x0, y0, if here you select x plus y0, it is not bad because z can be any number. So the bad case is x plus z0 or y plus z0, because x and y are 0, then you conclude z is 0. So here, at first, for these two parts, you should select that x0, y0, or x0, z0, or y0, z0. 3, choose 2. And then you say, okay, x plus z0, because for example, you've determined that x0, y0. So then you have two equations like this. You select one of them, 2, choose 1. And then you want to arrange them 3 factorial. To which equation be? For example, we have 3 equations. First one is x0, or second one or third one x0, and also other cases. The next, you select 2 from this level. You select 2 from this level, 1 from this level. 2 from this level means, for example, x plus y equal to 0, x plus z equal to 0, and 1 from this level. From these two parts, if x equals 0, then y equals 0, z equals 0, if z equals 0, so you can see that if you select any of them, your answer will be only 0, 0, 0, and these cases are bad. So first, for these two parts, you say 3, choose 2. Then for this part, you say 3, choose 1, then times 3 factorial. The other case, if you select 1 from this level and 2 from other levels, so it will be x plus y plus z equal to 0, and for example, 2 from other level, x plus y 0. Then from these two things, you conclude z is 0. Then you can say x plus z 0 or y plus z 0. Because z is 0, x will be 0, and x 0, y 0. All of them will be okay. So first, you should say these two equations are what? Any two of them are okay. Then which of them first equation, which of them second, which of them third, minus. If you select x plus y plus z equal to 0 and 2 from this level, then you say, okay, x equals 0 and y equals 0. So you will see it works because the only answer will be 0, 0, 0. For this part, you select 3, choose 2 times 3 factorial. And the next one, you select x plus y plus z 0. Then I want to select 1. If you select 0, 0, this one, and any of the two other things, for example, this one, this one, this one, then z can be any number. If you select this one, this one, this one, then you can select except 0, 0, 0 because it has no effect. If you select except these two other things, for example, this one, then y will be negative x, z will be negative x. For example, you can say x1, y negative 1, z negative 1. If you select, for example, this one, then you say, okay, x0, y0, z can be any number. If you select this one, x0, y1, z negative 1. So if you select 0 equals 0, it means all coefficients 0, then it is not bad case. So we don't consider that case. So we considered 3 from each of them, 3 from each level. We have 3 levels, 2 from one level, 1 from other level. Now I want to consider 1 from each level. So x plus z plus x plus y plus z 0. Now here x plus y equals 0. So here, if we say from these two parts, we conclude z equals 0. So the bad case here is we want to conclude that all of them should be 0. So here you say x equals 0 or y equals 0. So here for this part, you say 3, choose 1. And for this one, because you should select only x and y, if it is x plus y 0, you say 2, choose 1 times 3 factorial. Finish. We've calculated all bad cases. So let's see it will be what? Let me write with different colors. 8 cubed will be 512. Minus 3 factorial is 6. Minus 3 factorial is 6. Minus 3 times 2, 6. 6 times 6, 36. Minus 3 times 3, 9. Times 6, 54. Minus 3 times 6, 18. minus 3 times 6, 18, minus 3 times 2, 6, 6 times 6, 36. Okay, so here I calculate 512, and then I factor from negative 6. It will be 1 plus 1 plus 6 plus 9 plus 3 plus 3 plus 6. And it will be what? 1 plus 1, 2. 2 plus 6, 8. 8 plus 9, 17. 17 plus 3, 20. 23, 29. It will be 5, 1, 12 minus 6 times 29. And if you calculate this, let me show you here. It will be 512 minus 6 times 9, 54. We have 5. 6 times 2, 12 plus 5, 17. 12 minus 4, 8, 0. 10 minus 7, 3. 4 minus 1, 3. So the answer is 338. And the answer will be B. Okay, also in 10A, 12A, we had similar problems that you should consider different cases without formula. If you want to learn these important things, as I said before, feel free to send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 19. Okay, let's solve this problem. It says each square in a 5x5 grid is either filled or empty and has up to 8 adjacent neighboring squares. Why? Because look, for example, if you consider this, 1 neighbor, 2 neighbor, also if they have common vertex, it counts 1, 2, 3, 4, 5, 6, 7, 8 if it is here. If, for example, the cell is here, 1, 2, 3. Okay. Then it says either a side or a corner. Okay, the grid is transformed by the following rules. These rules are important. Any filled square with 2 or 3 filled neighbors remains filled. So if we have filled here, so let's analyze this. Let's read at first these 3 conditions. Any filled square with 2 or 3 filled neighbors remains filled. Any empty square with exactly 3 filled neighbors become a filled square. And this one, all other squares remain empty or become empty. Okay, so the first condition. Let's analyze here. Look, this part is filled, but it doesn't have 2 or 3 filled, so it will be white. So this one we understood. This one, it is white, it will be condition 2. It is empty with exactly 3 filled neighbors. Why? Because this one, this one, this one. So it will be black. This one is empty because 1, 2, 3, 4, 4 neighbors. But we have how many? 3 filled neighbors. And this one, why is black? Because this one is black. It says 2 or 3 is filled, 2 or 3 filled. So here we have 2. So this one will be black. This one has only 1 neighbor, will be white. This one has 3 neighbors. So it will be black. For example, this one has 2 neighbors, but because it is empty, it needs 3 filled neighbors. So it will be empty again. And this one, for example, I said has 4 neighbors filled, but because it is empty, it should have 3 filled to be black. Okay, so we've analyzed this. Analyze the rest of the problem. Okay, let's erase these parts. Then the problem says, suppose the 5x5 grid has a border of empty squares surrounding a 3x3 subgrid. Okay, how many initial configurations will lead to a transformed grid consisting of a single filled square in the center after a single transformation? Rotational reflections of the same configuration are considered different. When it says they are different, it means the problem is easier, because if they are same, you should pay attention. Or, for example, the things we've reached can be rotated or can be reached to each other by rotation or reflection, so it will be easier. And the figure are what? This figure, we should determine only this 3x3 to reach this. It is initial, it is transfer. So we should only pay attention to these 2 figures and the 3 rules that we have. Okay, let's see. I said if you want to consider different cases in the preparation video before exam, consider limited cases, the most limited case, and calculate that if you saw the preparation video before exam, again this problem is going to consider different cases. Here in this 3x3, what cell is good to work on? Maybe also you can work on other cells and you will reach the same solution. But I prefer to use this cell. Now let me tell you, I call this one A, B, C, D because I want to say, for example, which of them filled, which of them empty, and E, F, G, H, I. So look, if one of them filled, I say black. If one of them is empty, I say it is white. Okay? Empty, I call empty, white. So now here I consider E is black or white. Case 1. Suppose E is white. Because E is white, and now it is first condition, second condition, and third condition. By second condition. Because E here will be black. It says any empty square with exactly 3 fields. So there are 3 blacks. In other cells like in A, B, C, D, F, G, H, I. Now we know we have 3 blacks around this at first. If I have 2 adjacent blacks, with adjacent I mean have a common side, then let's see is it possible or not. So because we have 3 blacks, if it is black then it is bad because this one will be black here because by first condition this is black and 2 of the neighbors are black. So it cannot be black. Again, if this one is black, then this one has 2 neighbors which will be black. By similar way, it is not black because this one then has 2 blacks. If this one is black, then this white cell has 3 blacks in the neighbors, 3 black neighbors, and by second condition it will be bad, it will be black. But we know here it is white. Again, if it is black, this cell will be black in next step. If this one be black, again, let's check. Okay, so this one we will see that it will be good because the whites will be white, the black here will be white, and the middle one, the middle one will be black because it has 3 black neighbors. So if we want to calculate this type, this one, we should select what corner 4 times. Now, for example, this corner, here adjacent or here adjacent. So times 2, and the last one is 1. So we have 8 good cases. Now in this case, consider that we have adjacent that have same corner. Okay, this. So we know it is white. It is case 1. We set in case 1. E is white. E is here in the first step. And because we've considered the case that we have adjacent cells, black adjacent cells that have common side, so this one should be white, this one should be white. Because of this one should be white. Now the other black cells can be here, here, and here. If you have in this part, then we can see that this black cell has 2 adjacent, and by first condition here, this will be black here. Again, we have black, and it's bad. So the third black cell cannot be here, similarly cannot be here because it will be black in next step. If it is here, it will be good. But why? Because if you consider black cells, they don't have 2 or 3 adjacent black. If you consider white cells, except the middle one, they don't have 3 adjacent black. So it will be good. Now, I have 4 cases that these 2 adjacents are on what corner? This part, this part, this part, or this part. And the third cell is unique. It will be 4 times 1, which will be 4. Now in this case that it is white, we consider we don't have adjacent black cells. Not corners, not sides. So Here I say I consider different cases, that I select 3 corners. So let me count. Again, like the video I told you before, consider one property. I want to consider how many black cells are there in the corners, like this. If 3 here we have, then obviously we will reach this, and it will be 4 choose 3, which will be 4. Okay, now consider we have 2 cells in the corners, and they are not adjacent. So the only possible way here, not possible because only these 2 on the corners, we have this. And if you check black cells, don't have any, for example, 2 adjacent or 3. They have 1, they will be 0. Also 0 except middle one, don't have 3 black adjacent. So it will be 4. Because here they are on sides, on one side, they can be here or here or here or here. 4. The last one is unique. It will be 4. Now, if you consider the 2 corners similar to this, we don't have this. These are white, white, white. And it is not possible. You don't have any choice to select the next one. So it will be bad. So if you select 1 in the corner, then we can select here. It is white. It should be white. It should be white because adjacent, we've considered the adjacent cases, this one. Then here you can select 2 because they are adjacent again. And it is bad if you don't select from the corners. So for example, it is white, it is white, it is white, it is white. Then in these 4 points, 4 places, you can select 2 blacks. It's not possible to select 3 blacks. So in the case that the mid cell, the center is white, we calculated 8 here, 4 here, 12 plus 4, 16 plus 4, 20. So 20 in first case. Now, let's consider second case, case 2, that E is black. Okay. E is black in case number 2 and the midpoint is black. Now, adjacent by the condition of the problem, we have 2 blacks or 3 blacks to reach black again in the mid cell center. Now, if the cells here are adjacent, for example, if we have 2 blacks that are adjacent, then this cell has 2 blacks. If third one is adjacent to this, again, it has 3 adjacent blacks or 2 blacks. Both of them are bad because then it will be black again. So we don't have adjacent cells that are black. Now, if we select, for example, this one is black, if we select this one and say it is black, then see what happens. It has to be white because adjacent are not black. It has to be white. Now here, I should select one other black. So, because this is a white cell and it has 2 blacks, 2 adjacent blacks, it shouldn't have any other adjacent blacks, because if it has 3 adjacent blacks, it can't have 3, I mean. So you can select only one of them. If you select both of them, then let's see what's the problem, because then we have adjacent blacks and we said it is bad. If we have only 1 black here, it's bad because of this white. If you have 1 black here, it's bad because of this white. If you have 1 black here, it is bad because of this white. So here we can select. Similarly here, here, here. In this point, we can't select any black. Now we can say, okay, it is white. It was black in the case number 2. Then we conclude it is white because we've considered when it is black, it's impossible. It's this, it is white. Now, we need at least 2 blacks. If we select this one black, then this white cell will be bad because it has 3 adjacent black cells, and in the next step it will be black. So it is bad. So these 2 corners cannot be black. So the only possible case is opposite corners have to be black. So we have this case or this case. So we have 2 cases here. We've calculated 20 from previous case and 2 from this case. It will be 22. So the answer is C, problem number 19. Okay, it was considering different cases exactly with the same idea I told you before exam. Also, I solved 10A, 12A problems with the same idea. I can say most of the exams we have problems like this. If they don't have formula, you should consider different cases. You should find a property and consider different cases of that property. It is also useful in BMO other exams, AME, AMC, and also you can solve hard problems with this idea. If you want to learn these types of problem and other ideas and other problems, want to be able to solve them and improve your problem solving, description. Feel free to send message to my WhatsApp number in the description and comments. AMC 10B 2022 problem number 20. Let ABCD be a rhombus with ADC 46. Let E be the midpoint of CD, like this. And let F be the point on BE. So let's draw BE. Such that AF is perpendicular to BE. So AF is perpendicular to BE, and then it says what's the degree measure of BFC. This F, it will be something. So let's just consider, for example, this one, and this one, it's good now. We consider AF perpendicular to this, and we consider this angle alpha, and the problem says alpha is what? Okay, because we know it is a rhombus and we want to find the angle, so without loss of generality we can consider the side is 2, because if it's also 2x, there's no effect on alpha because the figure will be similar, so it will be 1 1 because it is midpoint, and it is 2. It is simpler for calculational things. Now let's work on other angles. We know it says it is 46. So for example, if we consider this angle beta, it will be 46 minus beta. And let's see what can we say. Let's try to use all things that we can. BF, here in this triangle, in triangle AFB. If I want to find BF, BF will be 2 cos 46 minus beta. Look like angle chasing and try to write anything that maybe is useful. And if we want to find BE, it is 2, it is 1. This angle is what? This plus 46 is 180, so it will be 134. So, by cosine rule in triangle ABCE, I say B squared is 2 squared plus 1 squared minus 2 times 1 cos 134, and we know that cos 180 minus alpha equal to negative cos alpha. So here I can say 4 plus 1, 5, and this one will be negative cos 46. Negative negative will be positive, will be plus 4 cos 46 degree. So we found B squared is what? Okay, now we are working, we want to find alpha, we want to work on cos alpha, sin alpha, cos beta, sin beta. Let's work on this part. We can say, if we use, so here cosine law, and the next part, I want to focus on beta. For example, in triangle BEC, if we use sine rule, I told before exam, sine rule, cosine law is what? EC over sine beta equal, look, EC over sine beta equal to B over sine 134. We know that sine alpha equal to sine 180 minus alpha. If two angles, some of them 180, sine of them are equal. So it will be B over sine 46. Now, EC is 1. So B equal to sine 46 times, let's calculate, because we've calculated B, let's calculate sine beta here. If I want to calculate sine beta, it will be sine 46 over B. B is what? B squared is this. So B is the square root of that. It will be sine 46 over square root of 5 plus 4 times cos 46. Now that we found sine beta, let's find also cos beta. If we want to, we know beta because here we have 46 minus beta. Beta is between 0 and 90. So cos beta, if you consider unit circle, when it is here, cos beta will be positive. So cos beta is square root of 1 minus sine, or let's write like this first. Cos beta squared is 1 minus sine beta squared because sine squared plus cos squared is always 1. It will be 1 minus sine 46 squared over 5 plus 4 cos 46. And if we use common denominator, it will be 5 plus 4 times cos 46. It will be 5 plus 4 times cos 46 minus sine squared 46. Okay. Now let's simplify. So here I consider 5 as 4 plus 1. 1 minus sine squared, so it will be 4 plus 4 cos 46. And 1 minus sine squared 46 will be cos squared 46 all over 5 plus 4 cos 46. Now, here we conclude cos beta squared, let me change this, cos squared of beta equal to, the numerator will be cos 46 plus 2 squared all over 5 plus 4 cos 46. Now, we can conclude cos beta, which will be cos 46 plus 2 all over 5 plus 4 cos 46. So, we found cos beta, the things that we've reached so far. We found BF is what? We found B is what? We found cos beta is what? We found sine beta is what? Also, we can find tangent beta here because in both of them we have same thing in the denominator. It will be sine beta over cos beta. So if you consider this and this, because the denominators are same, the denominators will be cancelled. So sine beta over cos beta will be sine 46 over cos 46 plus 2. Cos 46 plus 2. So we found also tangent beta. Now, let's use, because now we know BF is what? It is 2. It is alpha. This angle is also 180 minus alpha minus beta. So if we use sine law or sine rule in triangle BFC, then I can say 2 this 2 over sine alpha equal to BF over sine 180 minus alpha. Minus alpha minus beta. And we know that 100 minus 80, I told you. The beginning of the solution, it will be sine alpha plus beta. Okay. And we found that BF was 2 cos 46 minus beta. I told you here. BF 2 cos 46 minus beta. So I can say 2 over sine alpha equal to 2 cos 46 minus beta over sine alpha plus beta. If you divide both sides by 2, these two things will be cancelled, and then we cross multiply. Before cross multiply, let me tell you two things. Sine x plus y equal to sine x, cos y plus cos x sine y. These two formulas are so much useful, you should memorize. Cos x plus y equal to cos x cos y minus sine x sine y, and know that sine negative x equal to negative sine x, and cos negative x equal to cos x. Okay, so let's cross multiply this. So it will be only a rule. It will be sine alpha plus beta equal to sine alpha times cos 46 minus beta. Now, let's use the rules here I told you. Sine alpha cos beta plus cos alpha sine beta equal to sine alpha cos 46 cos beta plus sine 46 sine beta. Because look, if you use here, it's negative sine negative beta. It will be sine plus sine beta. Okay. Now here I have sine alpha here. I have sine alpha here. If I divide, let's see. Look, we have sine alpha. Sine alpha here, we have cos alpha. Because we were working on, for example, beta tangent beta. Let's divide both sides by cos alpha. And we know alpha, let's work. Can it be 0? No. Because alpha, if you consider unit circle, cos alpha in 0 and 180 is 0. And alpha is between 0 and 180. It cannot be 0 exactly or 180. If you divide by cos alpha, it will be tangent alpha cos beta plus sine beta equal to tangent alpha cos 46 cos beta plus sine 46 sine beta. Now in next step, if I want to calculate tangent alpha, I can say sine beta equal to, or you can rearrange them and take it to right hand side and then factor from tangent alpha. Then it will be sine beta over this coefficient minus this coefficient. It will be cos 46 cos beta plus sine 46 sine beta minus cos beta. It will be this. Now, let's divide both numerator and denominator by cos beta. It will be tangent beta. We want to work with tangent. Here, it will be cos 46. Here, it will be plus sine 46 tangent beta minus 1. And we know tangent beta is what? Tangent beta we've calculated. It is sine 46 over cos 46 plus 2. So it will be sine 46 over cos 46 plus 2. All over. So we have cos 46 minus 1. Let's write it. Cos 46 minus 1 plus sine 46 times tangent beta. So it will be sine squared 46 over cos 46 plus 2. If we simplify, let's multiply both numerator and denominator by cos 46 plus 2. It will be sine 46, and it will be cos 46 minus 1, cos 46 plus 2, plus sine squared 46. Okay. If we simplify, the numerator will be sine 46, the denominator cos 46, cos 46, cos 46 squared. 2 times cos 46 minus cos 46 will be cos 46. Negative 1 times 2, negative 2, plus sine squared 46. Now, it will be sine 46 in the numerator. Sine squared, cos squared 46 plus sine squared 46 will be 1. 1 minus 2 will be negative 1. So it will be cos 46 minus 1. Now we have a famous rule that it is similar to this because it is what we want to find alpha. It is tangent alpha. Okay. Tangent alpha, or let me write, for example, tangent theta equal to sine 2 theta 1 plus cos 2 theta. Now here, if you pay attention, we have negative here. What should we do? If you want to change it to 1, consider, let me write, for example, sine, you can say 134 over cos, negative cos, 134 minus 1. It is equal to this tangent alpha. And so here, for example, if you consider tangent negative theta, it will be negative sine 2 theta and 1 plus cos 2 theta. So we can say it is equal to negative sine 134 cos 134 plus 1. So it will be exactly, let me call it star, it will be exactly star, but theta is what? 5,667 degree. So it will be tangent by the formula negative 67. But we know alpha is an angle that we are working here. Let me show it on unit circle. This is tangent line. So negative 67 will be something like this. If you want to find the other angle that is equal to this, you should add 180 to that angle. So theta is, in this case, because it is negative theta. So negative 67 plus 180 degree will be this angle. So it is minus 67. It is minus 67 plus 180. So alpha, because it is between 0 and 180, the only possible case is this. 180 minus 60 will be 120 minus 7, 113. So the angle is 113 degrees. Okay, and let's select the choice. If you want to learn these trigonometric things, how to work with them, how to simplify, and these things in geometry, feel free to send message to my WhatsApp number in the description and comments. So the answer is D. And if you have question also, you can send message. AMC 10B 2022, problem number 21. Let p of x be a polynomial with rational coefficients such that when p of x is divided by the polynomial x squared plus x plus 1, the remainder is x plus 2. So let me show up to here p of x. When you divide it by x squared plus x plus 1, it will be q1x, the remainder will be x plus 2. And the next one, when p of x is divided by the polynomial p of x squared plus 1, p of x squared plus 1, this form is useful to write q2x, the remainder is 2x plus 1, 2x plus 1. There is a unique polynomial of least degree with these two properties. What is the sum of the squares of the coefficient of that polynomial? So we know always that because we've divided x squared plus x plus 1, consider the degree of p of x. P of x, it cannot be 0, because if it is constant, if we divide it by something like this, the remainder will be 0. So constant is not. If the degree is 1, then for example, it will be ax plus b. So let's check this one. Let's consider it is 1, it is 2. So by 1 ax plus b, if you divide by x squared plus x plus 1 times q1x, because the degree here is 1 and the degree here is 2, it will be exactly equal to this, and q1x equals 0. So a is 1, b is 2. And if you use second part, by similar way, ax plus b equal to 2x plus 1, a equal to 2, and that's a contradiction. So the degree is not 0, the degree is not 1. If you consider the degree is 2, so coefficient will be ax squared plus bx plus c. And we consider it will be x squared plus x plus 1. q1x will be a constant. Let's consider q1 plus x plus 2. Because if it has x, then what's the problem? Then we have degree 3 here. It will be this. It was first one, and by second one, ax squared plus bx plus c equal to x squared plus 2. The problem says x squared plus is divided by x squared plus 1. I have written x squared plus 2. Okay, let's check. Okay, so let's check again the first part. We've reached contradiction. Because we are working only by remainders, we can reject again 1. Let's reject 2. It will be x squared plus 1. Again, by the same way, q2 plus 2x plus 1. Now, here the coefficient of x squared, if we consider this, The coefficient of x squared in first part is a, and second part is q1. In this equation, it will be q2. If we consider coefficient of x, here it will be b. On right side, it will be q1 plus 1. Here again, it will be b. On right side, it will be q2 plus 2. Because we know q1 equal to q2, it will be q1 plus 2. So because of this part, 1 equal to 2, which is contradiction. So degree 2 is not possible. Now let's check degree 3. Okay, now because the degree of p of x is 3, so p of x equal to ax cubed plus bx squared plus cx plus d. Now, because the remainder here is 2, so I solved a similar problem in AMC 10A and 12A. It was what? I think 12A. I think in both of them. I'm sure in 12A we had that problem. If you consider an x that x squared plus x plus 1 equal to 0. For example, x squared, an x that x squared equal to negative x minus 1. Then in this case, p of x, because this part will be 0, p of x will be equal to x plus 2. So it means what? When x squared is negative x minus 1, x cubed is x times x squared, which will be negative x minus 1, which will be negative x squared minus x. X squared is this, so negative x squared. So x plus 1 minus x here, so it will be 1. Okay? Now, we understand x cubed is 1 in this case, so let's analyze all these things from this equation and the things here we've reached. If we analyze 1, p of x will be what? X cubed is 1, so it will be a. It will be plus b times x squared is negative x minus 1 plus cx plus d equal to 0, equal to x plus 2, the remainder. Now here, I say a minus the coefficient of x. On left hand side is negative b plus c equal to 1. And the coefficient of constant term, it will be a minus b plus d equal to 2. Okay, we have these terms. Now, if I find b, c, d, a, b, c, d that satisfy this, it's good. We can work on first equation. Let's use same thing for equation number 2. In equation number 2, I want to find x at x squared plus 1 is 0. So x squared is negative 1. So if I replace in p of x is ax cubed plus bx squared plus cx plus d. It will be a times x squared, which is negative 1, plus bx squared negative 1, plus c plus cx plus d. Equal to what? Equal the remainder. Equal 2x plus 1. So, here, if you consider coefficient of x, on left hand side will be negative a plus c equal to 2. And if you consider coefficient of constant term, negative b plus d equal to 1. Okay, now let's try to write all these equations. Negative b plus c equal to 1, a minus b plus d equal to 2. Let's see, can we find a, b, c that satisfy this? Negative b plus d equal to 1. It is because it is only correct for some special x. It is not necessary that all these equations will be satisfied. But it is sufficient. If we can find a, b, c, d that satisfy this, then we have the two equations that the problems want, and the assumptions of the problem will be satisfied. Here, we try to find a, b, c, d by replacement. Okay, so from this part, I say c is a plus 2. So I found c in terms of a plus 2. Also, I write c is 1 plus b. So I found c, let's see say something. Because c is a plus, I am thinking, a little better. Also, that way works. I say a is, if you take a, c minus 2, I write a in terms of c, and also b is c minus 1. If you take b, negative b to right hand side and 1 to left hand side, and then switch left hand side, right hand side, also similar way here. Now in this case, d is what? Is 1 plus b. Because we know b is d, so it will be 1 plus c minus 1. It will be 1, negative 1 will be cancelled, it will be c. Now if you replace here, a is c minus 2, negative b is c minus 1, d is c, equal to 2. So c negative c will be cancelled, so c minus 2 plus 1, c minus 1 equal to 2. So c will be 3. So d will be 3, a will be 3 minus 2, 1, 3 minus 1, 2. So A, B, C, D. A is what? A is 1. B is what? B is 2. C is what? C is 3. D is what? D is 3. So we found all these 4 numbers and satisfy the assumptions of the problem. The problem wants what? Sum of the squares of the coefficients of that polynomial. Okay. So it will be a squared plus b squared plus c squared plus d squared. A squared is 1, b squared is 4, c squared is 9, d squared is 9. 9 plus 9, 18 plus 4, 22, 23. So the answer of this problem is 23, and the answer is E. Okay, I've used exactly the same idea in AMC 12A. If you want to find these important rules, feel free to send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 22. Let S be the set of circles in the coordinate plane that are tangent to each of the 3 circles with equations. X squared plus y squared equal to 4, x squared plus y squared equal to 64, and x minus 5 squared plus y squared equal to 3. What is the sum of the areas of all circles in S? So, the equation of circle, if you have x minus alpha squared plus y minus beta squared equal to r squared, the center of this circle will be alpha beta, its center, and the radius will be r. So, we have these 2 things. Now, for each of them, the first one, center is 0, 0. Let's consider it is first one. It is second circle, third circle. So C1, let's consider centers and then consider radius. C1 is center, 0, 0 origin, and R1 is 2. C2, the radius center number 2. Again 0, 0, and radius number 2 is 8. C3 is 5, 0, and radius 3 equal to root 3. So let's draw these 3 circles. Okay, the 3 circles are these. We should find all circles that are tangent to each of the 3 circles with equations. So let's find all circles. So, okay, type 1 are these circles. If you want to find the radius of these circles, it has proved that these points are collinear. So suppose, for example, it is O1. So we know the radius is 2. Here it is R. And we know the radius here is 8. So 2 plus R equal to 8. So 2 plus 2R equal to 8. So 2R equal to 6. So R equal to 3. So we have pi R squared here, pi R squared here. It will be 2 pi R squared. So it will be 2 pi 3 squared. And 3 squared is 9. 9 times 2, 18. 18 pi. So let's consider other types of circles. Okay, in this case, we have another type of circle and we have 2 types of that. One of them, let me show you one of them. This one, and the other one, so let me just pay attention not to copy any other thing. Okay, the next one also will be this. Will be similar to that, yes, this one. Around these points, approximately. So, it will be this, but I calculate one of them multiplied by 2. So let's move it here. Pay attention to focus on this. So again, this circle, these things have the common point. Also these things you can see. Okay. So here again, if we consider O1 and the radius here will be 4 because the whole part is 8 and this part, oh no, let's see, let's make sure. Okay, yes, it is 2. The whole part is 8. Now let me tell you something. You should extend this and it will be the touch point. If you draw a little bigger, it will be this. It should be tangent. It will be 2. And then this part is what? R minus 4. Because it is R, it is 4. And this part will be R. So what can we conclude? We know this part is 8. So 2 plus R minus 4 plus R equal to 8. So 2R minus 2 equal to 8. So if you add 2 to both sides, 2R equal to 10 and R equal to 5. So pi R squared for this one, pi R squared for the other one I showed you in the beginning of this type, 2 pi R squared. It will be 2 pi 25, which will be 50 pi. So 50 pi here, 18 pi here. Let's focus on the third type. It is third type if we want to find again the radius. Here will be O1, R1, R1 to 2 plus 2R equal to 8. So R equal to 3. So we have something like this here. So it will be each of them pi R squared. It will be 2 pi R squared. 9 times 2, 18 pi. It will be the fourth type. And here, if we consider that, it will be tangent here. This one. If you want to prove that y, for example, these points are collinear, you can draw this. You can say O1, for example, M is perpendicular to tangent line. OM is perpendicular, so they should be same line, but they should be parallel, and also they have common point M, so they should be same line. So here we can consider it is R, and this part also will be R. So because it is 2, this part will be R minus 2, and R plus R minus 2 is radius of this. It is 8. It is also 8. R plus R minus 2, which will be the whole part. It will be 8. So 2R will be 10. So R will be 5. So we have two types of this circle like previous ones. You have, for example, something like this also here. So you say pi R squared for area of each of them. So it will be 2, 25, 50 pi. So let's see all the things we've reached. 50 pi plus 80 pi, 68. 68 plus 50 will be 118. 118 plus 18, which will be 136. So 136 pi, which will be E. If you have question or want to learn these types of problem, feel free to send message. My WhatsApp number, the description and comments. Working with circles, collinear, centers, solve problems like this. If you solve, it will improve your problem solving. AMC 10B 2022, problem number 23. Aunt Amelia starts on the number line at 0 and crawls in the following manner. For n equal to 1 to 3, Amelia chooses a time duration Tn and an increment Xn independently and uniformly at random from the interval 0, 1. During the nth step of the process, Amelia moves Xn units in the positive direction using up Tn minutes. If the total elapsed time has exceeded 1 minute during the nth step, she stops at the end of that step. Otherwise, she continues with the next step, taking at most 3 steps in all. What's the probability that Amelia's position when she stops will be greater than 1? Okay, so we know x1, all these things are between 0 and 1 because the problem says. So we conclude x1, x2, x3 and t1, t2, t3 belongs to this interval 0, 1. So it says the probability that Amelia's position when she stops will be greater than 1. So in first part, it cannot be greater than 1 because x1 will be less than 1. So the condition, if in second step they want to reach greater than 1, means P of T1 plus T2 greater than 1 probability of this, because then the end will be stopped, because it says if the total elapsed time has exceeded 1 minute during the nth step. So it is for second step. And then P of x1 plus x2 also be greater than 1 plus P of T1 plus T2 less than or equal 1 means it stops at last step, step number 3, but P of x1 plus x2 plus x3 will be greater than 1. We should calculate this. So let's calculate first this part, T1, T2. So if you want to consider T1, T2, you should consider it has two dimensions, T1, T2. You should consider the area. It is one important idea, also useful in other AMC problems. Also in CSAT problems for entrance exam of Cambridge. If you want to know these types of ideas like this, feel free to send message to my WhatsApp number in the description and comments. Okay, you consider 1 here, 1. T1, T2 are in this area, the whole area. But T1 plus T2 should be greater than 1. So if I draw another line like this, T1 plus T2 greater than 1 will be this area. So it will be 1/2. Because the area of this part over the area of this. 1/2 over 1, which will be 1/2. This part also will be, say, 1/2. This part will be the area of here. It will be 1/2. And for third part, we have three conditions here. We have three variables here, x1, x2, x3. So we should consider 3D. So if we consider this part, it is, for example, x1, x2, x3. Should consider 1 here, 1 here, 1 here. If I want to draw, it will be this part, for example, this part, and all of them will be 1. We should calculate the area of the volume of this inside this. If you want to calculate, it's better to draw a cube here to understand it completely. So if you want to find the area here, it means connect these things and try to find the area. It will be something like this. The area here, you can consider, for example, this altitude, this area, but a better one. This altitude, then the area of this part. So the altitude here is 1 times. The area here is what? 1 times 1 over 2 and over 3. And then over 3, because it is similar like this, a point that is connected to these things. The formula of volume is this. If you want to know all things about volume of different shapes, feel free to send message to my WhatsApp number in the description and comments. And the whole area is the volume of cube, which will be over 1 cube. Now, if we simplify, 1 over 2 times 1 over 2 will be 1 over 4, plus 1 over 2 times this part, which will be 1 over 6. And it will be 1 over 4 plus 1 over 12. And it will be 12, 3 plus 1, 4 over 12. Sorry, I've calculated less than 1 will be this. Because it is greater than 1, you should say 1 minus this area. So let me correct this part. 1 minus 1 over 6 will be 5 over 6. So it will be this part will be 5 over 6. And it will be this. 1 over 4 plus 5 over 12. If we factor from 12, it will be 3 plus 5, which will be 8 over 12. And if you divide both numerator and denominator by 4, it will be 2 over 3. And the answer will be C. Okay, if you have a question or want to learn same things like this, feel free to send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem number 24. Consider function f that satisfy absolute value of f of x minus f of y less than or equal 1/2 times absolute value of x minus y for all real numbers x and y. Of all such functions that also satisfy the equation f of 300 equal to f of 900, what is the greatest possible value of f of 800 minus f of 400? Okay, so let's solve this problem. At first, I say, if I use the things here, we have f of 800, let's call this one star, minus f of 400 is less than or equal, by applying star, 1/2 f of 800 minus f of 400. Now, consider f of 300 equal to f of 900 equal, let's consider it is r. So we know that f of 400 minus f of 300 by applying a star is less than or equal 1/2 400 minus 300, which will be 100 over 250. Now, f of 800 minus f of 900 is less than or equal 1/2 800 minus absolute value of 800 minus 900, which will be 50 again. It is r, f of 300 equal to f of 900, r. Now f of 800 minus f of 400. We call it also triangle inequality. Let me explain for you. Is less than or equal f of 400 minus r plus f of 800 minus r. Why? Look, absolute value of a plus absolute value of b is greater than equal absolute value of a plus. Now if you consider a is here and this one, you can say, for example, negative b is this, okay? So, because it's not important, if you say this, it is also correct for all a also, it is a plus b, absolute value of that is negative b. So, if you consider that all of them are correct, the sign inside is not important. So, this one minus this one. Or also you can say, for example, if you use the same thing here, a minus b is less than or equal absolute value of a plus absolute value of b. So this one minus this one will be this. And we can call this one triangles inequality. So we know this one by, let's call this one 1, call this one 2. It is less than or equal if you apply 1 and 2, 50 plus 50, 100. Now, we call this one 3. If you apply 3 here, it will be 100 over 2, 50. So the problem says find the greatest one. So we proved that the answer is greater than equal 50 or less than or equal 50. And you say the answer is less than or equal 50 because we've proved for all cases, for all functions, it is at most 50. Now, we can say 50 is the answer, but we should check, is it possible? Is it reachable? So let's try to find an example that satisfies the conditions of the problem and see, is it okay? So now, if you consider this function that it is, for example, x over 2 and up to what number? Up to 400. And it will be what? It will be 200 because it's x over 2, y. And for 300, it will be 150. And the next one, for 800, we have something here, for example, and also 900. We know 900 should be equal to 300. So let's consider this. Now I want to find a gap of, for example, between 400, f of 400 and f of 800. I want to reach 100, so it is 200. I consider this one as 100. Okay. If I want to find this line, and the slope will be what? Will be 100 minus 200. all over 800 minus 400, 400, which will be negative 1 over 4. So y will be negative x over 4, and 400 over 4, negative 100 plus 300. And for 800, it will be negative 200 plus this 100. And then this one, the slope again, if we consider x over 2. And for 800, it will be 400 minus 3. If we consider this, we can see that the difference has the same property that we want, and it satisfies the condition that f of x minus f of y is less than x minus y, half of x minus y, because in this part it's okay, in this part it's okay because it's x over 2, and this part also okay. If you consider, for example, a point and a point here, if we continue this, it was greater and it satisfies the condition. Now that it's here, they are nearer to each other, and we can easily, by the same way, prove these things. And the slope here is also negative 1 over 4, which is good. Now, what should we do next? In this case, f of 300 equal to f of 900 equal to 150, and also f of 800, let's consider exactly f of 800 minus f of 400. F of 800 is what? Is 100. F of 400 is what? 200. Now, f of 100 is what? Is 50. And f of 200 is what? Is 100. And their difference, the problem says, what's the maximum difference? Here, in this example, will be negative 50. You can negate all things, okay? If you negate all things, all the solutions will be satisfied, means all other things. So, for example, define g of x with this function that we've defined will be negative f of x. Then, if we calculate this, g of 800, again, by the same way, it's satisfied because if you negate this, it will be okay. And g of 300 will be g of 800 because it will be negative of f of 300 and not 900. You should only check these things. Let's see, it will be what? G of 800, it will be what? Negative 100. And g of negative 100 is what? F of negative 100 is what first? Will be negative 50. So g of that will be positive 50. Again, it will be this. Okay, I think you should reverse this. Let me tell you what should you do. Let's check this one. If you consider reverse of that, 300, 900, 800. So here y will be negative x over 2. We should also see we should add plus what. So let's first not write anything here. So here I want to reach something like this for 300, 150. For 400 it will be 100, and for this part we should have 200. So if you have this function y will be negative x over 2, and for 400 it will be negative 200 plus 300. And for this one, it will be y equal to, again, negative x over 2. For 800, it will be negative 400. And if you want to reach 200, it will be negative 400 plus 600. Okay, and this one, slope here, you can see 100 over 400. 1 over 4, x over 4, plus 400 over 4, 100, x over 4. And now it satisfies the first condition here like this. You say here is okay, here is okay, here is okay. Because if you continue, it will be okay. And now it will be better because it increased, then it will be decreased. Now in this case, let's consider f of 800 will be what? F of 800 will be 200. F of 200 will be what? So we use this. It will be negative 100 plus 300, 200. Okay. F of 400 will be what? Here it will be 100. F of 100 will be what, like here? Will be negative plus 250. 300 minus 50. The difference, so again here it will be negative 50, but we want to reach 50. Okay, try. Okay, so let's do something here. Let's, before 300, consider, let's consider this diagram, 45. Let's erase this part. Let's consider this part. Okay, so it will be x over 2. And this part will be y equal to negative x over 2 plus 300. And here it is y equal to x over 2. Okay. So if we consider this case, f of 800 will be 200. And f of 200 will be what? F of 200 is here. It will be 200 over 2, 100. Minus f of 400 is again 100. F of 100 again will be here. It's 100 over 2. It will be 50. So it's 50. So in this diagram, we've showed that 50 is reachable. So the answer is B. If you had questions about these problems, we're working with functions that are useful in also AME, USAMO. Feel free to send message to my WhatsApp number in the description and comments. AMC 10B 2022, problem 25. Let x0, x1, x2, and so on be a sequence of numbers where each xk is either 0 or 1 for each positive integer n. Define Sn equal to sigma from k0 to n minus 1 xk times 2 to the k. Suppose 7 times Sn is congruent to 1 mod 2 to the power of n for all n that is greater than or equal to 1. What is the value of the sum of this? Okay, again and again for this problem we should use small examples. I told a small example in the video exactly the day before AMC 1012A, and if you saw that problem here by small example, you can find the pattern, and then we can solve the problem, and also we can prove it by induction. So let's see. S1 by the definition is x0, and the problem says 7Sn. So for n1, let's analyze. 7S1 mod 2 is 1. So S1 mod 2 is 1. S1 is what? It's x0. So x0 mod 2 is 1. And because they are either 0 or 1, so x0 is 1. The first thing that we concluded. Now, let's consider n2. Again, another small example. S2 is x0. This form of problem solving is so much useful and it proves your problem solving, but there are some other levels you should learn after considering a small example. It is not finding only pattern. Find how to prove. And it's useful also in IMO problems. And we can solve completely those problems. x0 plus 2x1. And we know 7s2 mod 4 is 1. By the assumption of the problem, by here, if n is 2. From previous part, we found x0 is 1, so 1 plus 2x1. And if we replace it here, 7 mod 4 is negative 1. S2 is what? 1 plus 2x1 is 1 mod 4. So negative 1 minus 2x1 is congruent to 1 mod 4. Now, we take negative 1 to right hand side as negative 2x1 is congruent to negative 2 mod 4 plus 2, plus 2 mod 4. If you take negative 1 to right hand side, it will be positive 1. And then when we divide by 2, because 4 is multiple of 2, we should divide. We should divide by GCD of 2 and 4, which is 2. It is an important rule in modulo. If you don't know, feel free to send message to my WhatsApp number in the description and comments. Okay, mod 2. So x1 can only be 0 or 1, so x1 has to be 1. Now, the next case, x1 is 1. Let's check n3. For n3, s3 equal to x0 plus 2x1 plus 4x2. Now, x0 is 1, x2 is 1, so 1 plus 2 plus 4x2, which will be 3 plus 4x2. Now, S3, 7 times S3 is congruent to 1 mod 2 to the 3, which is 8. 7 mod 8 is negative 1. So negative 1 times S3, which is 3 plus 4x squared, 4x2 is congruent to 1 mod 8. So negative 3 minus 4x2 is congruent to negative 1 mod 8. Now we take negative 3 to right hand side, 4x, negative 4x2 is 3 plus 1, 4 mod 8. If we divide both sides by 4, let's divide both sides by negative 4. Then x2 will be negative 1 mod 2, or x2 is 1 mod 2 congruent. So we conclude x2 is also 1. Okay, if we consider x0 is 1, x1, 1, x2, 1. So let me write x0, 1, x1, 1, x2 also is 1. Now, let's consider n equal to 4. So, S4 equal to x0 plus x1 times 2, or 2x1 plus 4x2 plus 8x3. So x0, 1, 2, 4, which will be 7 plus 8x3. And also, we know 7s4 is congruent to 1 mod 16. Okay, 7s4 is congruent to 1 mod 16. Now, if we replace s4 with 7 plus 8x3, it will be congruent to 1 mod 16. 7 times 7, 49, plus 7 times 8, 56. X cubed is congruent to 1 mod 46, mod 16. Then if we take 49 to right hand, it will be negative 48 mod 16. Now, if we divide both sides by 8, 7x cubed, 7x3 is congruent to negative 6 mod 16 by 8 too. So here you can easily see 7 mod 3 is 1 and negative 6 mod 7 mod 2 is 1. So it will be x3, negative 6 mod 2 is 0. And because x3 can be either 0 or 1, so x3 has to be 0. So we found the first one, that is 0. So let's write it. x3 will be 0. Now, x4, let's write some more. If we consider n equal to, we've checked 4 and 5. So s5 equal to x0 plus 2x1 plus 4x2 plus 8x3 plus 16x4. x0, 1, x1, 1, x2, 1, x3, 0. So it will be 4 plus 2, 6 plus 1, 7 plus 16x4. Now, we know by the assumption of the problem, 7s5 is congruent to 1 mod, this part is 2 to the n, which is 32. And if we replace s5 with this part, it will be 7 plus 16 x4 congruent to 1 mod 32. Now, 7 times 7, 49. So we write 7 times 16, x to the 4, 49. Take it to right hand side, negative 48, mod 32. Now, let's divide both sides by 16. If we divide both sides by 16, 7x4 equal to negative 3 mod 2. If we consider all things mod 2, then x4 will be 1 mod 2. And because x4 can be either 0 or 1, so x4 will be 1. Now, let's replace. Here, x4 is 1. We've considered up to n5. Let's consider n6. And let's write n6. We can write it after this. Okay. n6. So s6 will be x0 plus 2x1 plus 4x2 plus 8x3 plus 16x4 plus 32x5. Now x4 is 1, x3 is 0. It is 1, it is 1, it is 1. And if we calculate this, it will be 7 plus 16, 23 plus 32x5. And 7s6 mod 64 is 1. Now, 7s6. 7 times s6 is 23 plus 32x5 is congruent to 1 mod 64. So, here 7 times 23 is what? 1, 4. Let's calculate 7 times 23, 21. We have 2. 161 plus 32. x5 is congruent to 1 mod 64. If we take 165 to right hand side, 32x5 will be negative 160 mod 64. And if we divide both sides by 32, it will be x5 is congruent to negative 5 mod 2. And it is also 1, so x5 is 0 or 1, so x5 has to be 1. So we've solved like this, x5, 1. Let's take one more case, x6, and then try to generalize this. So S6, if n is, we've checked up to n6, n7, then I can say S7 is x0 plus 2x1 plus 3x plus 4x2 plus 8x3 plus 16x4 plus 32x5 plus 64x6. So x0 is 1, x1 is 1, x2 is 1, x3 is 0, x4 is 1, x5 is 1, and x6 we want to calculate that. So it will be what? 7 plus 16, 23 plus 32, which will be 55, plus 64, x to the 6, and 7, s7 mod 1 to 8 should be 1. Now, if we replace s7 with this, it will be 7 times 55 plus 64 x6 is congruent to 1 mod 1 to 8. So, let's calculate. 7 times 55, it will be 385 plus 7 times 64, you can say it's 7. Look, instead of 7, you say 6 plus 1 times 64. x6 is 1 mod 1 to 8. But 6 times 164 is multiple of 1 to 8, so you can cancel that. It will be 0. So we conclude 385. 385 if we subtract. So let me write on left hand side 64x6, right hand side. 385 is congruent to, if we subtract 256, let's subtract 256 from this. 15 from 6, 9 will be 7, 2, 1 to 9. So if you take it to right hand side, 1 minus 1 to 8, it will be negative 1 to 8, mod 1 to 8. And then if you divide both sides by 64, x6 will be negative 2 mod 2, which will be 0. And because x6 can be 0 or 1, it will be 0. So here we found next 0. And we conclude x3 is 0, x6 is 0, and we guess. Let me write the things that we guess. x7 is 1, x8 with 1, x9, 0, and so on. And you can prove it by induction. I will prove, for example, x3k equal to 0. By induction, you can do the others as homework, and you can also comment your answers below this video. But first, let's solve the problem, then I will tell you proof of one of them by induction. So, x 2019 mod 3 is what? First, let's calculate this. 2 plus 1, 3 is 0. So, because we said the only things xi's that are 0 are x submultiples of 3, so it is 0. 2020 will be 1. 2021 will be 1. 2022 will be 0. So it will be 2 times 1 plus 4 times 1 will be 6. And the answer is A. And now, let me tell you the proof of, for example, why x3k is 1 and 3k plus 1, 3k plus 2 are same. So, suppose I know from, for example, x0 to 1 to 3k minus 1 is okay. I want to prove for 3k that x3k is 0. So, I consider s3k plus 1. It will be what? It will be x0 plus 2x1 plus 2 squared x2 plus 2 cubed x3 and so on. For example, plus 2, let's write some of them, plus 2 5x6 x5 plus 2 6x6, and at the end you write 2 to the 3k minus 2, a 3k minus 2, plus 2 3k minus 1, a 3k minus 1, and plus 2 to the 3k, a 3k. Okay. Now if we calculate, we know x0 is 1, it is 1, it is 1, it is 0, it is 1, it is 1, it is 0 again. And then if we multiply, if we want to calculate x 3k plus 1 first, it will be 1 plus 2 squared, then plus 2 to the 4 plus 2 to the 5, then plus 2 to the 7 plus 2 to the 8. Or let me tell you something. Oh, let me write first. Plus at the end, we write 2 to the 3k minus 2 plus 2 to the 3k minus 1 by induction. Sorry, it's not a, it's x. X, and plus 2 to the 3k, x 3k. Now, if we calculate from this part to this part, I can say it will be 1 plus 2 squared plus 2 cubed, 2 to the 3k minus 1, and then subtract, minus 2 cubed plus 2 to the 6 plus 2 to the 3k minus 3 plus 2 to the 3k x 3k. So if we simplify, first term here is 2 to the 3k minus 1. It is this part. And this part, you should know a famous identity. I said in most of my videos that r squared to r to the n equal to rn plus 1 minus 1 over r minus 1. Here, I've used r is 2. Here, r, we factor from 8 first, and then it will be 1 plus 1, 8 squared plus the last one is 8 to the k minus 1 because we factor, it will be 8k minus 2 plus 2 to the 3k x 3k. So here, let me not erase it to use it again. It will be 2 3k minus 1 minus 8 times. It will be 8k minus 1 minus 1, 8 minus 1, which is 7, plus 2 to the 3k x to the 3k. So now here, next level, it is what? It is equal to s 3k plus 1. Now, we know that 7 s 3k plus 1 is 1 mod 2 to the power of 3k plus 1. So we can say, if we multiply 7 by this, it will be 7 times 2 to the 3k minus 1 minus 8 times 8k minus 1 minus 1 plus 7 times 2 to the 3k x 3k is congruent to 1 mod 2 to the 3k plus 1. Now I can say 7 is 6 plus 1. So 6 times 2 to the 3k mod 2 to the 3k plus 1, because it is multiple of that, is 0. So we don't need to calculate that. And then 7 times 2 to the 3k, again you say 7 is 6 plus 1. 6 times 2 to the 3k is 0, because it is multiple of 2 to the 3k plus 1. So it will be 2 to the 3k and minus 7 for this part. Here 8 times this will be negative 8 to the k, which will be 2 to the 3k, minus this plus 8, and plus 2 to the 3k, x 3k is congruent to 1 mod 2 to the 3k plus 1. In this step, 8 minus 7 is 1, this one will be cancelled. And if we divide both sides by 2 to the 3k, it will be 1. We can also cancel 2 to the 3k and negative 2 to the 3k. So, and it will be 0 because we subtracted these things. If we divide both sides by 2 to the 3k, x 3k is congruent to 0 mod 2. So because x 3k can be 0 or 1, so x 3k will be 0. And I proved by induction. You can also, by similar way, try to prove that x 3k plus 1 plus 2 are 1. And x 3k is 0 is k at least, for k at least 1. Okay. So this was the proof of this problem. And again, I solved this with the same way of many problems we've solved before, also in AMC 10A, 12A, and the preparation video. I said consider a small example, then find the pattern, try to prove it. And if you saw my ideas, my videos, you could easily solve many problems in AMC 10B, also 12B, 10A, 12A, and also other exams. If you want to prepare yourself for AME and want to learn different ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments, because there are around 40-50 important ideas, formulas in each topic: combinatorics, geometry, algebra, and number theory. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. And please don't forget to subscribe, turn on notification, and like the video. Thanks for watching this video. Have a great day. See you next time. Bye bye.